Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-3 Part 1 homework solutions on piecewise functions. For number 1, we're given this piecewise function, and we have to evaluate it for -6 and 3 for x values. Let's do f of -6 first. So that would be the first case, since -6 is less than -2. So we have to use the first rule. We'll have 5 times -6 minus 9. That's -30 minus 9, which is -39. Now doing f of 3, 3 falls in this last interval, so we need the third rule, and this function just gives back a constant value of 10, so that's our final answer for that one. For number 2, we're evaluating this piecewise function for -6 and 3. -6 on this one falls in the first interval, so we need to use the first rule for this. So 4 times -6 plus 1, that's -24 plus 1, so -23. And then we're doing f of 3. 3 falls in the second interval between -5 and 4, so we need the second rule. So we'll do now 3 squared minus 6, so that's 9 minus 6, or 3. For this problem, we're being asked to evaluate this piecewise function here at 3 different x values. So let's take them one at a time. For the x value -2, so f of -2, that's going to be, let's see here, -2 is less than 0, less than or equal to 0. So that's going to fall in the first case for this piecewise function. So I'm going to take -2 and I'm going to plug it in for the x in this first rule here. So we're going to have 12 minus 9 times -2. So that's going to be 12 plus 18, which comes out to 30. All right, so for now, f of 2, 2 falls between 0 and 3, so that's going to be this middle rule that we have to use, the second case. So we're going to take 2 and plug it in for the x's in this second rule. We'll have 2 squared plus 3 times 2. So that's going to be 4 plus 6, which comes out to 10. And then finally, we're doing f of 6 for this last x value. 6 is greater than or equal to 3, so that's this third rule here, the third case. And this one's actually a constant rule. There's nowhere to plug anything in. It just spits back 4 no matter what you give it. So that answer is just going to be 4. No arguments there. On this problem, we've got this piecewise function where we're trying to evaluate 3 different x values. Looking at the different cases here, we have this linear case if you have an x value that's less than -3. We have this quadratic here for x values between -3 and 1. And then for bigger than or equal to 1, we have just the constant rule 5. So let's look at each of these one at a time. For f of -2, -2, looking at our 3 rules, -2 is between -3 and 1. So that's going to be our second case that we have to use here. So we're going to have to plug -2 in for the x in this quadratic rule. We're going to have -2 squared minus 3. And note here that I'm putting this in a parentheses. So that'll give me a positive 4 minus 3, which comes out to 1. Now for the next thing we have to do here, f of 2, 2 is bigger than or equal to 1. So that actually falls in this third case, which just always gives us the answer 5 no matter what we plug in. And then finally, f of 6, the last thing we needed to do, that also is bigger than 1. 6 is greater than or equal to 1. So we're again using the third case and getting a constant answer of 5 for that. For this problem, we are given this piecewise function and we need to figure out f of -10. So first I need to figure out which of these 3 rules -10 applies to. Taking a look at my range of values here, -10 is less than or equal to -10. It's this first rule here. It's right on the border, but -10 is included in this first rule because of the equals. So that means we have to use our first rule when we're plugging -10 in. So I'm going to do -10 squared minus 5 times -10 using this first algebraic rule. -10 squared is 100. -5 times -10 is 50. So we have 100 plus 50, which comes out to 150. And that's answer choice C. For number 7, they're asking us for the domain of this piecewise function. So there's two things you have to look at for a domain of piecewise functions. First off, we have to ask, are there any gaps within the individual rules? So any places where I'm dividing by 0 or square rooting a negative. And there are no x values where that's going to happen. So since there's no discontinuities within the rules, we just have to use the places where the rules apply and treat that as the domain of the whole piecewise function. So let's do these one at a time. For rule number 1, that applies if x is greater than 3. So we could write parentheses 3 comma infinity for that one. And then for the second rule, that happens if x is less than negative 2. So negative infinity comma negative 2 parentheses. And then for the domain for the entire function, we just have to these together, union them together. So we've got negative infinity comma negative 2 union 3 comma infinity with parentheses. And looking at the answer choices, that would be answer choice C. Notice they had answer choice D if you didn't realize that 3 and negative 2 were not included in the domain.